So welcome, this is the part 2 of the video having the questions from representation of data on S1 past paper questions. So the next question is from May-June 2017, question number 62. Annabelle measured the lengths of 200 caterpillars. Her results are shown. Find the median, 200. So it is 200 divided by 2, which is going to be 100. So from 100, I am going to draw the line. So it is over here and the graph and drop it down. So you can see that it is at 3.2. So what is going to be the median? Median is going to be 3.2. Then interquartile range. So for that interquartile range, again 200 divided by 4. This is for Q1, which is nothing but what? 50. From 50, draw the line. This is 60. Between 40 and 50, it will be 60. Between 40 and 80, it will be 60. And between 40 and 60, it will be 50. So this is 50. So from 50, draw the line, hit the graph, and drop it down. So it's going to be Q1 is 2.6. Q1 is going to be 2.6. Now I have to find it out Q3. Q3 is 200 times 3 upon 4, which is nothing but how much? 150. So 150. So this is 140. Between 140 and 160 will be there. 150. So draw the line, hit the graph, and drop it down. So which is going to be 3.7. So 3.7. So Q1 was 2.6, Q3 was 3.7. So interquartile range is going to be Q3 minus Q1, which is 3.7 minus 2.6, which is going to be 1.1. That's going to be the answer. Explain how many caterpillars had a length between 2 to 3.5 centimeters. So from 2, draw the 1 and get this 1. This line is going to be 24 and what is that? 3.5. From 3.5, from 3.5. From 3.5, draw the line, hit the graph and bring it over here. It's going to be 134. So I'm hitting the graph over here and it goes over, hits the graph. Be careful and see that it is 134. 134. So it's going to be 134 minus 24, which is 110. 6% of caterpillars were of length L centimeters or more. Calculate the length of L. So 6%. 6% is nothing but what? Of the caterpillars. 6 upon 100 times 200, which is going to be 12. 12 caterpillars. So what am I going to do? From 12, 4, 8, 12, I'm going to draw the line and hit it out over here. So what is the length he's been asking us to find it out. So instead of doing like that, what I can do is 12. So 200 minus 12, which is 188. So 188. So I'm going to draw the line from 188. So this is 180, 188. 88 will be over here. Hit the graph. See that it is hitting the graph. It's hitting the graph over here. Then drop it down. So when I drop it down, I can clearly see that it is at 4.5. 4.5 centimeters. Next question is from May-June 2017, paper 13. So, paper 63. The following histogram represents the lengths of the worms in a garden and calculate the frequencies represented by each of them. So, let's see that. Frequency is represented by each of the four histograms. What is he asking? He is asking us to find it out the frequencies of each of them. So first of all, what am I going to do that? I am going to find the heights. I am going to find the frequencies. Frequency density equals to nothing but what? Frequency divided by the class width. So what is the formula for the frequency? Frequency equals to frequency density times class width. Now over here for the first case, what is that? The class width. Frequency is nothing but how much? This is 4, right? And 4, the gap is 4 and this is 10. So each one is 0.4. So 0.4, 0.8, 1.2, 1.6 and 2. And the class width is 5. So 2 times 5, which is going to be 10. Now for this one, this is 8. 8 and the class width is 5. 8 times 5, which is 40. And for this one, it is 12. 12 times and the class width is 10, so 120. And finally for this one, it is between 4 and 8, so it has to be 6. 6 times class width is 5, which is 30. On the grid on the next page, draw a cumulative frequency graph to represent the lengths of the garden. So first of all, we have to find it out, length and cumulative frequency. Less than 5, less than 10, less than 20, less than 25. So it is going to be 10, 50, 170 and 200 cumulative frequency. Then I have to create a graph for that over here, then over here, then 0. I may take it as 5, 10, 15, 20, 25. Then this is I want till 200, so I can do it as 50, 100, 150 and 200. So cumulative frequency and over here length in centimeters. Now 0 is 0, then whenever it is 5, it is 10. It is 5, it is 10. The gap is 50 and there are 10 lines. So each line is 5. So whenever it is 5, it is 10. So at the second one, then for 10 it is 50. Then for the 20 it is 170, 150, 160, 170. And for 25 it is 200. For 25 it is 200. Now I am going to draw a smooth curve for this one. This is a cumulative frequency curve. Use your graph to estimate median interquartile range in the worms. So I have to do the median. So how many are there for the median? 200 divided by 2, which is 100. So from 100 I am drawing the line, hitting the graph. See that it hits the graph. Then maybe this point or this point I can take, and 100, hit the graph, then drop it down. It's going to be median. Then it is approximately over here. So what is that? This is between 10 and 15. What is the gap? 5, and there are 10, so each one is 0.5. So 10.5, 11, 11.5, 12, 12.5, 13, 13.5. So which is going to be 13.5. Now mark scheme gives you answer between 13.2 to 15.2. Any number between 13.2 and 15.2 is okay. So my answer 13.5 is correct. Now for Q1, which is 200 divided by 4, which is 50. So from 50, draw the line, hit the graph and do that. Already you know for that one is nothing but what? For 50 it was 10. Then for Q3, Q3 is 200 times 3 upon 4, which is 150. Do we know for 150? We don't know for 150. So from 150, draw the line, hit the graph. So we hit the graph there and drop it down. I'm dropping it down, so it becomes 15. Each line is 0.5, 15.5, 16, 16.5, 17, 17.5, and 18. So I got that answer as 18. And mark scheme says any answer between 17.5 to 19.5. So therefore my answer is correct. So therefore interquartile range is going to be Q3 minus Q1, which is 18 minus 10, which is 8. Interquartile range is going to be 8. That's going to be the answer. Calculate then estimate mean length of this one. So we have to calculate the mean length. So for calculating the mean length, we have to make a table. Between 0 to 5, the class is 10. So make a table. 0 to 5, it is frequency is 10. Then next frequency is 5 to 10, 10 to 20, 20 to 25. 5 to 10, 10 to 20, and 20 to 25. 40, 120, 30. 5 to 10, 10 to 20, 20 to 25. 40 and what were the frequencies? 120 and 30. 20 and 30. So this is X, this is frequency. So I have to find it out mid value. What is this effect? Midpoint. How do I find the midpoint? Which is 0 plus 5 by 2, 2.5, 0 plus 5 by 2, 5 plus 10 by 2, which is 7.5, 10 plus 20 by 2, 15, and this is going to be 22.5. Then I have to find it out fx. The formula is sigma fx upon n, which is going to be 2.5 times 10 plus 7.5 times 40 plus 15 times 120 plus 22.5 times 30 divided by 200. Simplify that, you should be getting it out 14 as the answer. Now going to the next question, question number 8. This is from October, November 2017. Question number, paper number 61. So he's taking the time taken by the car to accelerate from 0 to 30 meters per second is given there. Measure time seconds on the grid. Draw the cumulative frequency graph. So we have to draw the cumulative frequency. So first of all, we have to make a cumulative frequency table for that one. So I make CF. So what does that becomes now? 10. First one is going to be 10 itself only. Next one is 25. Next one is 42. Then 46 and 50. So I am going to draw the x-axis and I am going to draw a y-axis. Then 0, 5, 10, 15, 20, 25. Then again 10, 20, 30, then 40 and 50. This is cumulative frequency. This is time, seconds. Then 3 to 5 it is 10. At 5 it is 10. Then so basically what has happened is, this is, you should not take it as 5 because basically you should make the table as continuous. So this will become 2.5 and 5.5. This becomes 5.5 and 8.5. 8.5 and 11.5. 11.5 and 16.5, 16.5 and 25.5. So for 5.5 it is 10. So you should be doing it at 5.5, it is 10. 5.5, not 5, at 5.5 it is 10. Then for 8.5 it is 25. 7.5 and 8.5 it is 25. 25 is there between 20 and 30. For 11.5 it is going to be 42. 10, 11.5 is going to be 42. 11.5 is going to be 42. Then for 16.5 it is 46. 16.5 it is 46. And finally for 25.5 it is going to be 48. So this was not 50, this is 48. For 25.5, 25.5 it is 48. So when I join, this is the shape of the graph. 35 of these cars are accelerated 0 to 30 meters per second in a time more than t seconds. Estimate the value of t. 35 of the cars. So 48 minus 35, which is nothing but what? 13. 13 cars have what it says less than what it says the speed 0 to 30 in a time. Now what am I going to do that? So from 13 I am going to draw a straight line. So this is 10 lines are there and 10 parts are there, so each line is 1. 11, 12, 13. So from 13 I am drawing it out over here and getting this one. How much is that? Each line is going to be nothing but how much? 0.5. So this is 5.5 and 6. So answer is going to be 6 seconds. The mark scheme answer is between 6 to 7. Between 6 and 7. So therefore our answer is okay, fine. Now next one, Andy counts the number of emails. This is which question? Question from same October November 2017, paper 62. This time it is from paper 62. Andy counts the number of emails he receives each day and notes that over a period of n days, sigma x minus 10. So the coding is x minus 10 is 27, the mean number. So original mean. What is original mean? Original mean equals to nothing but how much? 11.5. So what will be the coded mean? Because the coding is x minus 10, the coded mean will be 1.5. Coded mean means nothing but what? Sigma x minus 10 upon n, which is 1.5. But what is sigma x minus 10? 27 upon n equals to 1.5. So n equals to 27 upon 1.5, which is going to be the value is n is 80.